Welcome back to my channel. In today's video, we discuss organotin compound. Organotin compound is tributyl tin hydride. Let's see. Tributyl tin hydride. Now, first of all, how can prepare organotin is first preparation. Preparation of tributyl tin hydride. First of all, when your tributyl tin chloride 4 moles is treated with lithium aluminium hydride, then we get okay 4 moles of tributyl tin hydride and side product is lithium aluminium tetrachloride. Okay, this is our tributyl tin hydride, which is reducing reagent. Okay, your tributyl tin hydride is a reducing agent because it having a hydride ion like lithium aluminum hydroxide. Now we some reaction of organotin compound. First is reduction of halides. Okay, the first application of organotin compound is reduction of halide. In the reduction of halide, when your tributyl tin hydride is react with halogen or halide to replace that particular halide with hydrogen atom. Let's see the reaction. General reaction first. Rx is react with tributyl tin hydride. Then we get RH. Okay, and side product is okay. This is free radical mechanism. Let's see the free radical mechanism. First is initiator. Okay, initiation reaction, your sulfur. Okay, this radical react with tributyl tin hydride. Then what will be happen? Then we get tributyl radical plus SH. Okay, this radical sorry, in this radical bond between hydrogen and sulfur. Okay, this type, and tributyl tin radical will be from. Then after next step, propagation. In propagation, what will be formed? In this tributyl tin radical is react with your halides. Then what will we get? Okay, R radical will be formed. Then this R radical again react with another molecule of tributyl tin hydride. Then we get tin radical. Okay. Got it? First, our alkyl halide is reacted with tributyl tin hydride. Then we get this halogen is replaced by hydrogen atom. Okay, this is a free radical mechanism. In this case, initiator, yes, radical is as an initiator, then propagation take place. Okay, shall I write this? Your alkyl halide reactivity with tin, their order is first upon iodine, bromide, then chlorine, and lastly fluorine. Okay, your organo-tin halide is selectively used for reduced geminal dihalide into monohalide compound. Okay, let's see the example. Let's see the example is, okay, it's treated with tributyl tin hydride. Okay, then what will be the product form? Which alkali first reduce or replace with hydrogen atom? Your chlorine. Okay, we already discussed their reactivity order. Then we get this geminal dihalide geminal dihalide converted into monohalides. Okay, here only reduce chlorine. Then again another example. Here in this example, both halogens are chlorine. Here we get this type of the product. This hydrogen, these halogens are replaced with that hydrogen atom. Okay. If in case of alkyne, what will be the happen? In this example, we get two product. Okay. First is a rearranged product. Okay, let's see the mechanism, or we can write down the product. There simply free radical mechanism. We get CH3 triple bond and CH2 radical, which is again formation of bond, and here then we get CH3 C radical double bond, again double bond, CH2. Okay, and simply here CH3 C triple bond C CH3. Okay, after the addition of hydrogen, then we get CH3 CH double bond. No, I think एक दो तीन चार. Okay, this carbon having a 1 2 3 4. Okay, this two product will be formed. Now we discuss next point is dehalogenation followed by intramolecular carbon-carbon coupling. Okay. Now the next point is dehalogenation followed by intramolecular carbon-carbon coupling. Let's see the example in which what will be the product form? Like this type of the product will be formed. First, let's see the mechanism for this product. We know that it is a free radical mechanism. In this, here, formation of radical. Then we get diradical species, or simply we can form the bond between this radical and this radical. Okay, which is primary radical, highly unstable, but how can reaction is carried out for that particular. Okay. After that, your tin butyl tin hydride formation of this bond and formation of that, like that structure. Okay, this is TBH, means tributyl tin hydride. Okay, simply simple example, if your triple bond is present and your tributyl tin hydride, then what will be the product form? Here only simple this type of mechanism, only formation of double bond. Okay, this triple bond is reducing double bond. Show the mechanism as simple. Okay, here and again tributyl tin hydride providing the hydrogen, and we finally get okay. We discuss another example for carbon-carbon coupling. It is very easy free radical mechanism. Here, okay, this is any alkyl radical, cyclic alkyl radical, or is treated with CH2 double bond CH CO CH3. What will be the product in presence of tributyl tin hydride? Okay, what will be the product form? Simply, we already say dehalogenation followed by intramolecular carbon-carbon coupling, where the coupling will be formed radical formation at this alkene and this alkyl. We get this halides are replaced. Okay. Oh, sorry. Here, CH2. Okay. This mechanism also simple. Here, formation of radical. This double bond again, formation of with this carbon coupling, and here a radical, another radical. Okay. And this radical, okay, formation with hydrogen bonding, formation with bond with hydrogen. Okay, then finally we get CH2, CH2, CO, CH3. Okay, it is very simple. Before coupling with carbon-carbon bond. Next point is reduction of acid halides using organo-tin compound. Let's see the example. RCOCl is reacted with tributyl tin hydride. Then we get aldehyde and ester product. Okay. Let's see the mechanism is free radical mechanism. Okay. In reduction of acid halide, we get aldehyde and ester. Let's see the mechanism. It is a free radical mechanism. First of all, here formation of radical. Okay. Let's see the mechanism. We know that it is a free radical mechanism. Okay. Your tributyl tin hydride undergo the formation of a radical. Okay. Then we get BO3SN radical and hydride radical. Okay, simple. After that, this tributyl tin radical is react with RCOCl radical. Okay, then what will be the happen? In this state, your halogen okay depart and formation bond between halogen and tin. Okay, then we get RCO radical and side product is Bu3SnCl. Okay, what happened in next step? Okay, this in first step your hydride radical or hydrogen radical is formation bond between this and this. Then we get aldehyde RCOH. Okay, we get this first one. Then after the aldehyde formation, okay, then we simply formation of ester. Okay, or you can show this mechanism in next step also. Okay, RCO BO3 SN hydride, then we get RCOH. Okay, and side is BO3 SN radical. Okay, completed. The next step we discuss. First of all, look here, reduction of acid halides. We having the acid halide. This is mechanism is free radical mechanism. First of all, tributyl tin hydride is undergo free radical mechanism formation of tin tributyl tin radical and hydride radical. This tributyl tin radical is react with acid halide. Then we get RC double bond O radical, acyl, acyl radical. Then your tributyl tin chloride form. Then after this, this radical formation of bond between again tributyl tin hydride. Then we get finally aldehyde. In formation of ester, we discuss the formation of ester. Shall I rub this? In this, having the acyl radical, and aldehyde molecule. Then this radical, okay, this radical formation bond between the carbon oxygen and forming a new radical on a carbon. Then we get R C double bond O carbon and oxygen, formation of new single bond between the carbon and oxygen, and here forming the radical. Okay, we get this type of the species, and again this species treated with tributyl tin hydride. Then we get R C double bond O CH2 R. We get ester. Simply, na? This radical formed between the bond. Okay. This tributyl tin hydride and this ester radical. Okay. Formation of this hydrogen bond, new hydrogen and carbon bond. Okay, and we get ester. We again discuss another example. You can try that particular mechanism. Okay, another example, C6H5COBr. Okay, acid halide. Okay, what will be the product form? Tell me. First product is aldehyde. Okay, and another product is ester. C6H5COOCH2 C6H5. Okay, CH2 C6H5. Formation of first one is aldehyde, another one is ester. Okay. Now we discuss next application, reduction of carbonyl compound. Next application of reduction of carbonyl compounds using tributyl tin hydride. When your carbonyl compound is reduced, then we use alkoxide. This alkoxide which is react readily with water or another protic solvent, then which is gives alcohol. Okay, let's see. RC. Okay, this is your ketone is reacted with tributyl tin hydride. Then what will be the product? R dash CHOH. Okay. Now we discuss the mechanism. Again, see, free radical type of mechanism. Okay, negative and containing positive charge, or simply then what will be the product? What will be the next step? R dash CHO tin. Okay, like that, which is alkoxide. This alkoxide react with water. Okay, this is alkoxide is reacted with water. Then simply we get R dash CHOH. Okay.